Okay, guys, so we've been working with fractions a little bit already. And I'm going to let you know, I've fallen a little bit in love lately with adding, subtracting mixed numbers. And the reason is, I do it different than my teacher taught me how to do it. And I think it's easier, and I think it makes more sense. When my teacher taught me how to do this, I had to make both of these things improper fractions, get like denominators and do it, and there's an easier way. Okay? And that is by not making these improper fractions. But what do you notice about my chunks?
They're different. They have to be different.
Right now I have fourths and I have thirds. Not the same size chunks, so I can't mess with it. I need to make same size chunks, which means twelfths. So the first thing I'm going to do is rewrite my whole problem with 12 in my denominator. And remember, I like to do that, so then all I have to focus on is finding my equivalent numerator, right? Once I do this, it's like I've almost got it finished. So, how did I get from 4 to 12? Times 3. So I do it to my numerator. I get 9. How do I get 3 to be 12? Times 4. Do it to my numerator. I get 8. Nothing happened here except getting same size chunks. It's the same exact numbers. They just look different. All right? We cut them into different pieces. So now, what you want to do is you want to subtract your whole numbers first, or add. But in this case, I got a positive and negative. They fight, and I get 7. And then you're going to want to mess with those fractions, which I got a 9 minus 8 for 1. So that one works pretty nice. Once you get like denominators, that one works pretty nice. I'm going to show you one that doesn't work quite as nice. But I also think it's still kind of really fun. All right? We're going to do 8 and 8/9 plus 8 and 2/3. So do I have same size chunks? No. Notice I like to say same size chunks instead of the same denominator. Because one tells us what's conceptually happening, and then some kids will hear denominator, and it's just a math word, right? So what size chunks can I get these both to be?
9.
I can get them both to be 9. So I set everything up except my numerators. And in fact, I don't have to mess with that first one. I don't have to mess with the 8/9. It can just stay 8/9. Cool. So how did I get that denominator of 3 to become 9? I cut it into pieces to make, cut them into 3. And that gives me 6 out of 9. If I had 2/3 to get 9, I'm going to cut them each into 3, right? That's why I multiply by 3 to get 9. Cool. So just like last time, we're going to add our whole numbers. So 8 plus 8 is 16. And I'm going to add my fractions. 8 plus 6, 14. So what? Anybody notice something? Owen, I saw your hand go up. You notice anything with our answer right now? Well, it's already simplified, actually. We need to make it mixed appropriate. Meaning, I've got a mixed number, but then I've also got an improper fraction in my mixed number. So we have to make it a proper fraction. What that means is there's an additional whole in my fraction, and right now my fraction portion should only represent the part. So if I'm looking at this fraction right here, I need to move over one whole. How many ninths is that one whole? How many ninths is one whole? How many? 10 ninths would be one more than a whole. 9 ninths is one whole. So I like to imagine, see that little line? I like to imagine kind of sucking out a 9 ninths there, putting it over with the 16. What does that turn the 16 into? 17. Right? I'm taking one whole. By the way, 9 divided by 9, or the fraction 9 ninths, what's 9 divided by 9? 1. 9 ninths is one whole. 4/4 is one whole. 12/12 is one whole. So I'm going to take that whole out of 14 ninths or 9 ninths of it, and that leaves me with 5. Right? I'm using 9 of these to make one whole. That would leave me with 5 left. That's why there's still 5 9ths. Cool? Do you see how I'm pointing the concept instead of steps? Concept instead of steps. All right. So it's just like, guys, what that's really like, it's not like adding. When you get like 15 when you're adding two numbers and you drop the 5 and carry the 1, have you guys done that before? Like drop a 5, carry a 1? That's the same thing.
What's the one where you like take like so it'd be like so we have 8 and then 8 over 9 and then we do like 8 times 9 and then
That makes it improper. You don't want to make it improper when you have mixed numbers because you're going to get huge numbers to work with. And then you might have to make it back into a mixed number, which is more work. All right, we need to look at a subtraction one. And this is where, that thing we were just talking about, Owen, where I like to keep it mixed numbers. This is where it's just so much easier. Okay, so our chunks aren't the same. What kind of chunks do we want?
we could just do 10s too.
Tenths. We want tenths, yep. So I'm going to rewrite everything with tenths. And Owen already identified. We're going to do times 2 to make this equivalent fraction. So that's going to give me 6 tenths there. Now, subtraction, we can also subtract whole numbers and subtract fractions. But what do you notice right here when you try to subtract those fractions? Can you do 6 minus 9? I mean, you can and get a negative number, but it doesn't make sense because this number is bigger than this, which gives us a positive answer. So check this out. I notice I can't do 9 minus 6 or 6 minus 9. So just like subtraction, when I have something like 15 minus 8, or maybe not 15, let's do 75 minus 8. When you can't do 5 minus 8, what do? You borrow.
Not the 11.
Okay? Let's do this like a thought bubble. I'm going to borrow from my whole number. So I'm going to borrow one whole. 11 becomes 10. And one whole comes over here as a fraction that has
16.
10 tenths are going to come over and make it 16 tenths. Oh, and you were right there. But do you see why I can make that 16 tenths? My whole is 10 tenths. I'm just taking that whole as a fraction and putting it with my fraction.
Because you couldn't put it with the fraction because the fraction's small.
Correct. So just like borrowing with the subtraction, that's what I'm doing. I'm borrowing. And in this case, that whole is 10 tenths. So now we can sit there and subtract our whole numbers. So 10 and a negative 8 is 2. And then you can go and subtract your fractions. 16 tenths minus 9 tenths. That's 7 tenths. Guys, the understanding of what to do between these two things is not much different once you understand what and why you're doing it, all right? And that's why I love mixed numbers, because my teacher had me do this. They had me do 58 fifths minus 89 tenths, multiply this by 2, get 116 tenths, minus 89 tenths, right? See all that crazy stuff I'm doing there? This is a lot of work. I'm even going to stop because I'm like, remember, a lot of work's not bad, but there's an easier, more efficient way. All right? Cool.